I posted a video 2.5 months back where I talked about the 7 real world projects that you can do to enhance your DevOps skills. And I talk about, certifications are good for getting started, but you have to build some real world projects. And the results were very positive for that video. Thank you so much for that. But one of the common asks after that video was, hey, you showed us what projects we can do, but could you, make those projects and show us how to do it, right? So in this video, I'm going to start doing that. And the first one I'll be showing is this particular project that we will build today. And this diagram is very simple, but I'll dive very deep into, what are all the components involved here, etc. But, next one will take up, we will automate that entire thing with Terraform and so on, right? But one thing is, if you already know these basics and all, right, so one of the projects was around GitOps, and you can take a look at this one. I've already created a playlist where I talk about Argo CD, etc., and you can go through this one. I've already created that particular thing. But yeah, over the course of a couple of months, I'll be creating all these projects. And yeah, let me know what you think. So let's get started with this first one. And basically, this is what we'll do. It's very similar to the diagram that I showed, but to dive deeper, what we'll do is we'll create a network, and then we'll create VMs in US region, Europe region, Asia region. So what we are doing here is we are building a globally scalable web service here, and we'll see how we can scale it to multiple region. If a VM goes down, then what we should do, or if a VM goes down, what will happen, and if we hit with some traffic, lot of traffic, then how it scales automatically, etc. So I talked about this, like why this is a very good starting point for your cloud or DevOps journey, because you'll be getting a sense of what cloud is and what are the advantages of cloud is, right? Like here I'll be using VMs, but ideally I want you to think in terms of compute. So it can be Kubernetes in the backend, it can be something serverless like Cloud Run or Lambda, etc. So yeah, here I'll be using compute engines, which is equivalent of EC2 in AWS. But I'll be creating them in US, Europe, Asia, and then I'll be hitting them using the DNS that I'll have, and then it'll go through the load balancer, and then it will land to appropriate region based on where the request is coming from, right? So that's what we'll do here. So in the process, this is what we'll be creating. We'll create a network, we'll create subnetworks, we'll also create firewalls. And then in terms of compute, if we have to automate the entire auto scaling thing, and if a VM comes up, the web service should already automatically be installed in it. We need something called instance template, managed instance groups, etc. We'll be creating load balancers, A records, we'll be creating health checks, etc. And also that, whenever the service is down, then automatically it will be removed from the managed instance group, and then it will be a new one will be coming up. So I'll talk about load balancer while I'll be creating. There are a lot of components involved in load balancer when configuring it. We'll also configure certificates so that we talk over port 443 rather than port 80. So that's the overview. So without further ado, let's get started. So I'm already into my Google Cloud Console, and I'm already logged into my project and my account. But if you want to come to Compute Engine, I've already pinned it here. So you can click on Compute Engine and come to VM instances, or you can type here Compute Engine and then click on the Compute Engine from the drop down, and you will land it here. So in order to build whatever we saw, right, which is this particular thing, let's get started here. Let's first start with the network, right? And for that, I'll go to VPC, and I will not cover VPCs in detail, but I'll quickly go ahead and create a VPC network. And from the project, you can see that I am a big Star Wars fan, and this Mando host project, and Mando in Star Wars refers to the Mandalorian. So I'll name my all resources on the Star Wars theme. So if you would have seen Star Wars, you would see that there's a Death Star you know. So I'll name my network Death Star, and then I'll mostly keep everything automatic, so that I don't dive or spend too much time in the network section. But you can also choose custom and then add your subnets here, and you can create a subnet in the three regions that I mentioned: US, Europe, Asia, etc. But I'll keep it automated, so that everything comes up for me, or is taken care of me automatically for all the regions. But let me know if you want to see a deeper dive into VPC networks. I can talk about shared VPCs, routes, firewalls, peering, network connectivity center. There are a lot of concepts in networking in any cloud. But let me know if you are interested. But yeah, to create a network, I'll just keep everything default. I'll keep the default policies, and here you can see it's along for port RDP, SSH, and I have some deny all ingress, etc. So yeah, I think that is good, and let's go ahead and then click on create. So once this is done, what I'll do is I'll create some firewall policies in order for the traffic to get in. I need some fire policies as well, right? So what I'll quickly do is I will create some firewall policies through the command line. Let me go ahead and use Cloud Shell here, and this is still coming up. So let it first come up, and then I can go ahead and then create the firewall rules. Okay, it is up now. So the command that I'll run here is I'll create a firewall rule, and in GCP what happens is the load balancer, in order to see whether the instances are healthy or not, sends probes, right? And again, I don't want to dive too much deeper into it. I can cover maybe if I make some video around networking, but it sends probe so that it can see which instances are healthy, which are not, so that it can make sure to only send the request to the healthy instances or the VMs, right? And the load balancers request or the probes will come from this IP. So that's what I'm doing here. I am creating the firewall rules from this particular IP. Now this is successfully created. Now if you can also do it through the firewall console over here, right? And what you can do is you can create a firewall rule, but I'll not go ahead and then create anything over here. But yeah, you can also create it manually, but I think that's fine. And in the next, I think in the next project, everything will be created through Terraform. So, it will be anyways automated, but I just wanted to show the look and feel of CLI and the UI as well. So now the network is in place. Let's go ahead and create the instance templates and the instance groups. And for that, I'll go to Compute Engine, and let's create all those things. Okay, once we land here, if we go to instance template, and let's build all of these components over here for US region, Europe, and Asia. So instance templates, create an instance template. Let's name it TIE Fighter, and IT for instance template. Let's keep it global, and I'll use E2 micro, because when I hit the load on this particular website or this particular VMs, I want them to easily get or utilize all the resources, right? But the idea is simple, which is we are trying to replicate a very highly global web service. So I just want to make sure that I don't spend enough time or resources just to make sure that it is using all its resources like CPU, memory, etc. So that's why I'm choosing a very low scale VM, but you can choose a VM with very high configurations like N2D, etc. But yeah, once this is done, I will go to here, and I will choose my network and the one which we created, which is Death Star, and subnetwork. I will click on auto subnet because this is a global one. So I want to make sure that I'm not tied to any particular subnet over here. And then I will choose ephemeral IPs. And the last thing I'll do is automation, where I will add a startup script to install Apache. I'll do apt update and apt install Apache. Okay, now once this is done, I'll hit on create, and then I'll go to instance groups, and then create all my instances, instance group or managed instance group using that particular instance template. So let's start with the first one. I'll name this TIE Fighter in US Central 1, and instance template, I'll use this one. Let's scale this in multiple region because we want to make sure that it is highly available in its region and then across regions as well. So that's why I'm selecting multiple zones. US Central 1. Target distribution is even, and this is the most important thing, which is auto scaling. Add and remove instances to the grip. So the minimum will choose 1, maximum will choose 10. Now we can add multiple signals over here, and what I'll do is I'll add based on HTTP load balancing, and I'll choose 80% over here. And what this basically means is, so our instance size is very small, so we'll assume that it can handle 100 requests per second, and whenever we will have 80% of that 100 requests per second, which is 80 requests per second, then scale an instance, right? And keep doing that until we reach the maximum instances or we get below this 80% of utilization. So yes, initialization period is wait 60 seconds before either starting the health checkups or sending any traffic to the VMs. And I'll create a health check as well very quickly, and I'll say name this TIE Fighter health check, and I'll use this health check for everything. Protocol is HTTP, Apache will run on port 80, and let's just tweak this one. Check interval, let's increase this, and let's save. Rest all, I think it's good. And one thing is you can find the equivalent bash script over here as well, and you can just take this and automate this if you want. So I find this very handy feature as well. So let's click create, and by the time this is coming up, let's also create the other 2 instance groups in other regions. So we'll name them TIE Fighter in EU West 1. Let's choose Belgium, and we'll use this one, and multiple zones here as well, and here we'll just choose EU West 1. So this even will keep the same configurations as previous instance group. Okay, and rest all is fine. We'll also assign a health check to this one, which is the same as the previous one, and click on create. And the last one, which is Asia, and for this one let me choose my hometown place data center. So I will name this TIE Fighter Asia South. Let me check the region for Delhi, which is Asia South 2. Nice. And let's repeat the same thing over here. That's fine. Signal type is load balancing 80%, and health check will be TIE Fighter health check, which will do a health check on port 80. And yeah, if a VM is unhealthy and if something goes bad, then this is the health check which will ensure that the VMs are brought down and then a fresh one is brought up again. Okay, so now this is done. We should have our 3 instance groups in place. 2 of them are coming, one is already up, and we can see that it's saying that okay, since you have chosen HTTP load balancing as the signal type, you will have to make that configuration as well, and that's what we will do now. So we'll go to load balancing. You can either search for load balancing here, or you can go on the console here, network services, and then load balancing. So here what I'll do is hit on create load balancer, and this is very interesting part. I love load balancers. or I should say, Google Cloud load balancers, because we have so many options, and you can find like the appropriate load balancer for every use case. And in this case, we are running a highly available and highly distributable web service. So it will be an application load balancer. So I'll choose that one. It will be public facing or external, and I'll choose global one because our workloads or the web servers are in multiple regions. So I'll choose this. If they would have been in just one region, then I would have chosen this one, but I'll choose this one. And then I will choose advanced traffic management or basic, but I'll go with this one, and then I'll click on configure. Now, as I mentioned before, a load balancer, you have to do multiple configuration. So I can maybe cover this in some other separate video, but the whole point of going through this was that you go through all these configuration and make yourself very familiar with all these concepts as well. That's why I mentioned that this should be your first project, because the plethora of services that you will be experimenting with are too much, right? And load balancer you will use with no matter which compute you are using in the backend, be it GKE, be it a cloud run, be it something else, etc. Right? So any compute there has to be a load balancer, right, to make sure the traffic is distributed appropriately and you can do a lot of configuration. So in Google Cloud, a load balancer is built up of basically four components. There is a forwarding rule, a proxy. You can attach a certificate with that if it's a HTTPS proxy. Then you have an URL map, and you can make sure to host based, path based routing here. And then you have the backend service, which is maybe a GKE or your managed instance groups that we just created. So let's configure them, and I will name my front end as, let's say, Millennium Falcon. And if you don't know, Millennium Falcon is the fastest ship in the entire galaxy of Star Wars. So I love this Millennium Falcon. So do watch Star Wars if you haven't. And yeah, I'll choose HTTPS as the protocol here. You can also go with the basic one, but I just want to give you the flavor of what production will look like. So you will never use HTTP. You'll always use HTTPS, which will run on port 443. Now you choose a certificate. So I've already created a certificate here, but you can also create your certificate by just creating a Google managed certificate over here. Write your domain name, etc., and then you can create it. So I've already created it, and I will use that one, and then hit on done. Now next up is your backend configuration, and this is where you will create your backends and then map it with the URL map, because we have already done these two steps. So let's go ahead and create the backend. Name it TIE Fighter backend instance groups. But this is what I mean by exploring right here. So you get to see all these options. So dive deeper into what does these mean, right? Like, okay, if you choose the serverless next network endpoint groups, then you can have your backend as something like cloud run, cloud functions, etc. Right? So whenever you have a chance to explore that, but in this particular scenario, I'm using instance group. I'll keep the protocol as HTTP because our web server is running there. Now let's select the TIE Fighter instance groups. So let's choose this one. Port number is 80. I'll choose balancing mode as this one, rate, and then this is what I mentioned in the auto scaling section, which is the RPS will be 100 requests per second, and we chose there that our uh, the utilization should be 80%. So whenever there are more than 80 requests per second to a particular instance group, then the load balancer and the managed instance group will talk with each other, coordinate, and then scale up. So this done. Let's add another backend. Let's add the Europe one. Port number is 80 and rate 100. Done. One more time. Rate and okay. So this is done. And then you have cloud CDN as the option, which is content delivery network. You can cache some static content, etc. here. So I have a very very simple website. I don't need this, but you can enable this and go through all these TTLs and etc. But again, I can cover this maybe in networking section, etc. But for this particular video, I don't need that. But in a production website, definitely you need caching mechanism. Health check, I'll choose the same one. I don't need logging, but it's a good practice to enable logging in production. And then by default you can have cloud armor, which will protect you from DDoS, WAF. It acts as a web application firewall, etc. So you can keep it enabled or you can keep it false. Let's keep it enabled. It doesn't matter for our use case. And then I don't need session affinity. So basically you'll need session affinity if you want your request to go to one particular instance based on client IP, some cookie or header field, etc. I don't need this. Mine is a stateless application, but there might be some legacy application or your application which might need session affinity, so you can keep that. And load balancing policy, I will keep round robin. So we have multiple mechanisms here. So round robin basically is it will target first instance, second instance, third instance, then it will target the first again, second and third. So it will keep on round robbing it. But you have least request, ring hash, random, maglev. There are a lot of options. So go ahead and then you can learn more about them in the documentation as well. So a lot of configurations here. You can add your custom headers, response, but I don't need that. I'll just quickly go ahead and then hit create. I have my backend, hit OK. And for now, I think this is good. You can add more backends, but I don't need that. Routing rules for now, it's good, which is simple host. So any request go to these backends. You can also select advanced, but I don't have that use case. And then I'll finally come to review and finalize. And here you can review all your settings. Now, one thing about load balancer is, and I will show this in the logging section or the monitoring section by sending some traffic here. So whenever a user is sending a request from Asia, it will go to the instances on these instances, right? So this is a very good feature of our load balancer, where it will just have one IP, which is called anycast IP. You can read about anycast IP, etc. But what it does is there will be a single IP, and that single IP will the load balancer will decide that, okay, this request is coming from Asia, send it to the Asia backend, right? And if Asia is down or full, then send it to Europe or other regions, right? So I'll show them as well this functionality, but that's a very good feature of the application load balancer. So click on okay, I didn't name my load balancer, but I will name this Millennium Falcon, the fastest spaceship in the entire galaxy. So this creating, but meanwhile what we can do is we can go to our instance groups, and I'll open this in a new tab, and we can check the status of our instance groups. So you can see here there is no backend service attached to this instance group, which is okay. Once this load balancer will come up, that error will go. So let's wait for some more time. Okay, so this load balancer is up, and if I quickly click on this, you'll see that the certificate is assigned. So if you go here, you can see that the autoscaler is configured to scale based on load balancing signal, but the instance group has not received any queries. Check the load balancer configuration is working or not. So if I come here and click on my certificate that I created, so it's saying failed not visible. All right, and what this happens is because in the backend what Google Cloud does is so we have the IP of the load balancer, so you have to make sure that you assign this IP to the domain name for which you have created the certificate for, right? So that's what we will do. So if I go to cloud DNS, and you can see that I already have the Google Cloud POCs.dev, and I've gone here and then created this A record just now. So if I click on this one, this IP is exactly the same as the IP of the load balancer over here. So you have to give it some time, so that's why it will not work straight away. So if I go here, paste this, what you can see that, error SSL version or cipher mismatch. So it will take some time, so let's give it some time and then we'll come back and then try again. So it's been some time since I updated my A record here with the IP of the load balancer. Now this is a very important step, as I mentioned before, that you must do this if you are using an HTTPS based load balancer and you are creating a certificate for this particular domain. So if I go to my certificates now, you can see that the certificate is active, and that's because I pointed the IP of the load balancer to the domain name. So let's go to this over here and then click refresh, and you can see the website comes up. So this is very exciting, and at this point of time we don't know from which server this is being responded to, but I in New Delhi, so I'm sure this will be coming from the New Delhi region. But if I go to any other region and try, like for example Europe, I'm sure that that request will be serving from the Europe region. But let's go to instance group and hit refresh here. You'll see that these are still like in warning state, but these will also come in green after some time. So let's go back here, and one thing that I wanted to show here is monitoring, and this is what I wanted to show. So in the past couple of hours, what has happened? So it is showing your load balancer has no traffic yet. The diagram shows configuration of the load balancer, right? So whichever request comes to slash, then go to this TIE Fighter backend, and here we have three backends, right? So let's create a VM, or I already have a VM, and let's go to that VM and then you know hit that with some traffic. So, and let me first go ahead and then install Siege, and now I will do Siege -c 150 and our domain name. Okay, so this is starting the siege. So let's wait some time. Now this VM is in US Central 1, so all the requests should go to US Central 1 region, but we can confirm that. So most all the requests will go here, and then this will auto scale, and if this can't serve any more traffic, then the request will start coming to Asia South 1 and then EUS 1 region as well. So I've been running that load testing for the past 5 minutes for now. Um, but the thing is, the threshold that I have here, which is 80% for the backend service, it's too high for the scale up of the VM. So that's why if I go to compute engine, you'll not be able to see any scale up. So if I go to instance group, so for now most of my traffic is coming to the central region. So if I go to central region here, you can see that the number of instances is still 1, and if I go to monitoring, you can see that the siege is running, but it's still at like 10% utilization. So what we'll do now is we will edit this, and here we'll go to the setting that we did, which is HTTP load balancing here, and we will say that okay, let's make this 10%, so that we can see the scale up and all those things. So 100 RPS, and the 10% of that is 10. So I'll keep that this tab opened as well, and I will open a new tab, or I'll go to my shell here, and I will create a new instance for EU region, and then I will siege from there as well. So let's wait for this to come up, and meanwhile this setting is also getting updated, and this has been updated. So we'll see a lot more instances coming in the US Central 1 region now. But meanwhile, what I'll do is I'll create an instance in Europe region, and I will hit the Europe region now to make sure that the traffic is coming from Europe as well. Because if I go to the load balancer today, you'll see most of the traffic here is going to the US central region. So if I click on this details, you'll see that the RPS mostly is in the Europe region, because the load balancing test that I did, it's from the Europe region. So let's also now do some load testing in this EU region and make sure we have some numbers here as well. So yeah, let's do that. So let's go to our Cloud Shell, and this is up and running. And what I will do is I will do gcloud compute SSH, the instance name. Okay, we are inside, and then I will again run the siege command. Let's see, let's use 200 users, and let's take this URL. Great. So now this is running. We'll see some requests coming here as well now. Now let's wait, and I'll show you the results after maybe 10 minutes. So one thing I just wanted to pitch in is that now we can see two instances in the US Central 1 region, and you can see that this one just came up recently. The health checks also passed for this one. Okay, so this has been running from past 2-3 minutes, and we can see the two instances in US Central 1 region. And I think, yeah, here we still have one instance for the EU West region, but this will also scale. But if I go to load balancer and go to monitoring again, we'll be able to see now some traffic is coming to the EU West region. So if I click here, and if I go here, you can see that the rate now is 8 RPS for this one, and 0 for Asia South 2. This has increased from 0, and we can see some traffic going there as well. Now let's do one thing. Let me open another tab, and let's test this in Asia region as well. So I'll copy the same commands. Okay, this is up. Now let's SSH into it and run our siege command. Okay, so this will now send the request to Asia region as well, for which there's very little traffic, which is this one. And this is the graph. You can see the request which are going to the service. So you can see the numbers fluctuating here as well. Now let's do one thing. Now let's go to the Europe region, and let's make sure to edit this one, the utilization for this one as well, from 80% to maybe, let's say, 5%, so that we see more auto scaling happening. And what I'll also do is I will open one more tab and then create one more load testing instance in Europe. And what I'll try to do is I'll try to add more strain to the servers in Europe region, so that we see a lot of auto scaling happening and a lot of traffic going there. So the idea is I'm just trying to show you the capabilities. Okay, so I've started 3 tabs, and 2 of them are sending traffic to Europe. The other one is sending to Asia. So the Europe one should have the highest number of traffic, and we'll see that in a couple of moments here. But the idea is I'm just trying to show you how a truly scalable website looks like in production, right? So we have the certificates in place, we have the appropriate managed instance groups in place, we have the appropriate auto scaling in place, so that the VMs come up based on certain utilization. We have the regions covered, etc. So that's what I wanted to cover, so that you get the entire idea Okay, so now we have some traffic coming to Asia region as well. And here you can see that, we have some instances coming in the Europe region. So if I go to this tab over here, and let me come back to this tab. So you can see that, I have 9 instances which are coming up because, I have two load testing instances sending load to or live traffic to the pods in Europe region. And these are showing timeout because they are just coming up. But yeah, they just came up. They knows the maximum number of instances. What will happen is, each one of them will handle, the traffic, and whenever the traffic reaches 5 requests per second, then the VM, they have already auto scaled. But that was the behavior that I had set, which is whenever 5 requests per second was hitting one instance, bring up another node. Right now, all of these, if they are hitting, if they are serving 5 requests per second, then the traffic automatically will now be redirected to US Central 1 and the Asia South 2 regions. So that's the benefit that you are getting here, that it's automatically scaled up in that particular region, and the request is automatically being transferred to other regions based on the serving capacity. So yeah, if I come here and let me click on, let me refresh this page one more time. Come here, view details. You'll see that 10 of 10 instances have come up, and they are serving 16 requests per second. And as you can see, this graph is also increasing, every minute, because I'm running tests from 4 different VMs. And I showed the scaling capability of the US West region, and the traffic will also go to the US Central 1 and Asia South 2 now. So one experiment I also wanted to do was, what happens if I delete the VM? How will my website handle it, and how will it react, right? So what I'll do is, I am in Asia region. I'm not using any VPN, and this is working fine. And what I'll do is, I only have one instance for Asia region, which is running in Delhi. And you can see that for Europe, US, the it's scaled to 10. Now it's resizing back to 6. And for US Central, it's scaled to 4. Now it's resizing back to 2, because I stopped some of the load tests, etc. So it's again scaling back, so that it's not spinning up VMs without any purpose. So you save a lot of costs, etc. And that's the main advantage of cloud, right? The flexibility and the, we call that, elasticity that you get with cloud. So you don't have to manage that and manually scale up, scale down, etc. But let me show you that particular scenario. So I'll go ahead and I'll go to VM instances, and I'll search for the Asia South one, which is this one, and I'll delete this. Now this is getting deleted, and what I'll do parallelly is, I'll go to instance groups, and you'll see that this is resizing and it is transforming. But meanwhile that is happening, right? Let me hit refresh. See, this one didn't had any effect at all. Now let me open maybe another profile. So if I go here as well and run this, I'm in Asia region. I don't see any difference at all, right? So this is one aspect. Like, even if I delete multiple VMs, my website will keep on running, right? So one final thing before I wrap this video up is, I wanted to show the entire scale up, scale down that happened throughout this 1 hour session, right? So as you can see that, earlier the VM was at 1, and then it scaled up to 10 instances, came back to 6, and then again back to 1. So this is where we started our siege, or the traffic. We did the load testing, and then it scaled to 10. Then we stopped the load testing, it came back to 6, and then when we fully stopped it, it came back to 1 again. So this is what you can see here. in this particular graph. And as a DevOps engineer, you have to be good at observing things and observability, which is alerting, monitoring, logging, etc. And this is one aspect of it. So you can see the entire thing, what happened. So for example, here the CPU went up as well for those instances, and the earlier I had the capacity set at the rate set at 80%, but to demonstrate the load balancing and the scale up, scale down mechanism, I brought it down to 5, right? So that's what you see in the graph as well. So I brought it down to 5, and then you see this autoscaler utilization as well. And when it came back to 5 again, the number of instances again came back to 1. But in between, when it was high, the number of instances were also high, etc. So you can see and look at all those things from this particular monitoring dashboard. And in the long term, you have to learn about how your systems are behaving, etc. as well. This is just one thing you can see for managed instance group, but you can get the same kind of metrics and utilization for any kind of compute like Kubernetes, cloud run, any serverless compute, etc. Right? So this is just one thing I wanted to cover as well. So yeah, I think this is what I wanted to show in this particular video. Hope this gave you enough idea about everything that I intended to cover, like how the DNS is configured, how the load balancer is configured, and I can summarize the DNS part again, where I added this record to this particular host name, and then I added the IP of the load balancer here, so that the certificate is created. So in order for the certificate to be created in Google Cloud, you have to map the IP of the load balancer to your domain name. Then only this will, you'll see a green checkbox over here. Otherwise, it will not work. So we did that. We worked on load balancer, and in load balancer, there were already like hundreds of configurations that we did. We chose the backend from various regions. We configured the certificates over here. We chose some of the routing rules. Okay, basically it was the default one, which is whenever request comes to slash, then go to any one of the backends based on the region. So those all things we configured. We didn't enable the CDN policies, but you can enable that as well. We configured the health checks, and then initially we started from compute engines, where we created the instance templates, global instance templates, and then we created the instance groups. And and this is our you can say fully global website in action. So you can try it for yourself in your particular environment, and in the next video I will walk you through the Terraform code of this one, so that you get the entire idea of how to automate this entire application. So give a thumbs up if you like this video. I know it was a long video, but it had to be, because I wanted to give you an overview of what cloud is, what are the benefits of scalability, availability that you get out of the box in any cloud provider. And I hope you got the idea of that. And keep exploring, and let me know in the comment section if you have any questions. Now, if you like this video, I mentioned that I have already created the Argo CD video. Now, until my next video comes up with respect to replicating these entire things with Terraform, you can go ahead and then watch the Argo CD bootcamp. I've covered from basic, what is GitOps, Argo CD, how to install it, etc. And I am sure you will like this as well. So until then, you can watch this particular video. I'll leave a link of that in the description, as well as on the top right section. You'll see that now. Yeah, until then, I think keep learning, keep exploring, and have a great new year. Thank you so much.